Hey y'all, we're going to do some of assignment 3.4 together today. Let me pull up the screen. All right, so we're talking about the chain rule. As you can remember, that's the one you have like an inner function and an outer function. You can kind of think about it as layers of M&M or an onion. So let's look at this. The first question says, find the derivative of 3t plus 11 to the 2/3. So we see this outer part of the function is this raised to the 2/3. So we're just going to pull the 2/3 down, subtract 1 from the power because it's n x to the n minus 1 for the power rule, and that would be negative 1/3. Now the inside stays the same. I always say don't chew the chocolate. So we keep 3t plus 11 as it is, but then on the same line, you multiply by the derivative of the inside, which is 3. Then you can try to simplify these 3's simplify. And so we have 3t plus 11 to the negative 1/3. This one is 9x squared plus 2. And this, when you have it like this, that is the cube root, is 1/3 power. And so we're going to bring the 1/3 down, subtract 1, subtracting 3/3 makes this negative 2/3. Keep the inside the same. And then we multiply by the derivative of the inside, which in this case would be 18x. Now, when we multiply 1/3 times 18, as you can multiply these three parts of the function in any order, I know that 18 is divisible by 3. 3 goes into 18 6 times. So we can put the 6x in front just to make it look a little nicer, plus 2 to the negative 2/3. This one, kind of a general rule of thumb, is if you have a root or a fraction, you want to rewrite it. So I can bring this whole thing up to the top. I should say fraction if it only has one function of x. If this had a 3x on top, we need to do the quotient rule, but since it's just a 3, we don't need to do the quotient rule. So when I bring this to the top, if you have 1 over x cubed, when you bring this up, it's x to the negative 3. You just switch the sign on this exponent. And if you don't remember exponent rules, I have a very quick recap video. It's maybe like 3 minutes or so. You can look on my YouTube channel. So this would be to the negative 3 power. So our outer function, or like the shell function, is this raised to the negative 3 part. We're going to bring the negative 3 down, so that'd be negative 9. You subtract 1, so that'd be negative 4. You keep the inside the same. And then you multiply by the derivative of the inside, which is 3s squared. And then you can just look across here and multiply 9 times 3, that's 27. So negative 27s squared, s cubed minus 6 to the negative 4. Now this one, all of these 4, 5, 6, 4, 5, and 6 are a little bit different because you have the chain rule, and within the chain rule, you also have the product rule, the quotient rule, because you have two functions of x. So that's the difference here. This one, I have a first function, x, and then I have a second function, 4x. So I have this guy, and then I have this second part. So we're going to say the derivative of the first times the second plus the derivative of the second, which this is the chain rule, times the first. So I'm going to simplify this here by just looking across. Now, when I'm looking across the whole function, sometimes students will get confused. This plus sign here is separating. This is something you can multiply these together over here, and then you have plus these guys you can multiply together over here because of order of operations. So if I was going to rewrite this, I would just write 4x minus 5 cubed plus 3 times 4. I can multiply these because multiplication is commutative. So 12x, 4x minus 5 squared. You could factor out a common factor here. This answer is fine with me. This one, let's rewrite the root. 25 minus x squared to the 1/2. This is, again, product rule because we have two functions of x. It's also chain rule for this part here. And this one's going to use chain rule. So we're going to say the derivative of the first, which is 2x, times the second. I'll use a different color. Times the second one without changing it. We just write the second one down. Then plus, now we're going to do the derivative of the second. So that's when you bring down the 1/2. You subtract 1 from the power. Makes it -1/2. You keep the inside the same. But then you multiply by the derivative of the inside, which the derivative of 25 is 0. The derivative of -x² is -2x. And then times the first. So derivative of the first times the second plus derivative of the second times the first. As far as simplifying this 2 and that 2 cancel, and x times x² is x³. You could write the x to the 1/2. You could write that part in the bottom if you want. 2x 25 minus x² to the 1/2. Let's see, plus, and then I have a minus here. So it would be like minus x³. And then I could put that in the bottom, 25 minus x², the square root in the bottom. Or you could leave it as the negative exponent. So that's that answer. The next one is similar to that, but it's the quotient rule. I'm just trying to see. Okay. So we're going to do the quotient rule here. So the derivative of the top is 5 times the bottom. Then quotient rule is minus the derivative of the bottom, which you bring the 1/2 down because this is like x² plus 8 to the 1/2 power. So you bring that 1/2 down and then you subtract 1 from that 1/2. That makes it -1/2. You keep the inside the same, but then on the same line, you multiply by the derivative of this, which is 2x. Then times the first. So again, derivative of the first times the second minus the derivative of the second times the first. For quotient rule, you put it all over the bottom squared. When I square the square root, you're just going to get the bottom like that. This 2 and that 2 could cancel, and you could write this at the bottom if you want. Let's see, I can write 5 square root of x² plus 8 minus x times 5x. It's 5x². And then I have over x² plus 8. The square root of that over x² plus 8. Well, that was kind of messy. If you want to get rid of this square root here, you can find a common denominator here, or another trick is you can multiply this top by the thing that would make this go away. So basically multiply it by the square root of x² plus 8, because that would make this cancel out. And so you would have to multiply by that on top and bottom though, and then distribute it to both things. And so if I did that, this answer right here is correct, just so you know. It's just if I'm trying to simplify it and I need to check and see what answer WebAssign is wanting as far as how simple to go. 5 times the square root of x² plus 8, the square root of x² plus 8. Well, when you multiply the square root times itself, you just get x² plus 8. Then minus is just going to be 5x², because when you multiply this times this is going to cancel with that. Over on the bottom, you have this times this. Then you can multiply this through, so we get 5x² plus 40 minus 5x², so those 5x² cancel. And so our final most simplified answer would be this. All right, the derivative of sine, if you remember the derivative of sine, is cosine. So we just replace the cosine sine with cosine. So it's going to be 5 cosine. The inside stuff stays the same, but then you multiply by the derivative of the inside. Now remember, the derivative of 2x is 2. The derivative of 3x is 3. So the derivative of 7 pi x is just this, the coefficient in front of x, which is 7 pi. So you could simplify that by multiplying those two things together, 35 pi, cosine 7 pi x. Tangent goes to secant squared. So secant squared, you don't chew the chocolate, don't change this inside, but then you multiply by the derivative of 8x, which is 8. So 40 secant squared 8x. Okay, so this one is a little tricky. When you have a trig function and this notation is written with the 6 inside like that, you're going to put 6 on the outside. So when I move the 6 down, 6 times 8 is 48. Keep the secant by itself. Move 6 to 5 because you're going to go down 1, then you're going to multiply by secant. Secant's derivative is secant minus tangent. And then you have to look and see, is there anything left? And there's this 3 layer. It's like you have a peanut M&M. So it's like you got a shell, you got the chocolate, you got the peanut. So this very last thing, you got to look in here. What's the derivative of pi t minus 9? It is pi. So this very long thing as your answer. Now you could write 48 pi together, and this is a secant to the 5th and a secant. So that's secant to the 6 pi t minus 9, and then tangent pi t minus 9. E is one of the easiest rules ever. E to the u is just e to the u du. So it's just e to the negative x squared, 6 times the derivative of that, which is negative 6x to the 5th. This one is product rule, so you have to do the derivative, and we know it's product rule because there's 2 functions of x. Okay, so the derivative of the first is 2x, then times the second one, then plus the derivative of e to the something is e to the something times the derivative of this, which is negative 5, and then times the first, because product rule has these 4 parts: derivative of the first times the second, derivative of the second times the first. So 2x e to the negative 5x minus 5x squared e to the negative 5x. And then this one is quotient rule. Okay. Similar to what we just did, except it's a quotient rule problem. So derivative of the top would be 5 e to the 5x, because you multiply by the derivative of the exponent, times the bottom. Quotient rule does minus the derivative of the bottom, which would also be 5 e to the 5x, times the top, all over the bottom squared. So if I multiply this through, e to the 5x times e to the 5x is 5e to the 10x plus 40 e to the 5x minus 5e to the 10x. So this cancels with that. And so you would get 40 e to the 5x over e to the 5x plus 8 squared. This one is product rule also because you have 2 functions of x. So derivative of the first times the second plus, product is plus, p, product plus. The derivative of natural log of u is the derivative of u over u. This is the chain rule part. So it's the derivative of the stuff. What's the stuff in here? 7x. The derivative of that is 7 over 7x times the first. Derivative of the first times the second plus derivative of the second times the first. So that 7 cancels, and one of those x's cancel. 14x ln 7x plus 7x. And then this one, determine where that graph has a horizontal tangent. A horizontal tangent is just a way of checking to see if you understand. Tangent means derivative. It's the slope of the tangent line is the derivative. Horizontal means the slope is equal to 0. So we take the derivative, we set it equal to 0. So this is going to use the chain rule and the quotient rule because it's a quotient. So derivative of the top times the bottom minus the derivative of the bottom, which would be 1/2 2x minus 1 to the negative 1/2 times the derivative of the inside times the top all over the bottom squared, which just make it go away like this. So let's clean this up here. That is negative 4 square roots of 2x minus 1. These 2's cancel. So a negative and a negative makes a positive 4x over the square root of 2x minus 1. Or 2x minus 1, if you remember my trick from earlier, if I want to get rid of that, I can just multiply by the square root of 2x minus 1 on top and bottom and distribute this. So I get negative 4 plus, negative 4 times 2x minus 1, because 2x squared to 2x minus 1 times the square root of 2x minus 1 is just going to be drop the square root plus when I multiply this times this, that's going to cancel with that. So just 4x. And then on the bottom, you get the square root of 2x minus 1 times 2x minus 1. So if I distribute the top, negative 8x plus 4, and then plus 4x. So the top is going to be negative 4x plus 4. And really, whenever it asks where something's horizontal, you just care about where the top equals 0. So negative 4x equals negative 4x equals 1. Make sure that doesn't make the bottom equal to 0, because if it did, the function wouldn't exist there. If I plug 1 into the original function, I'm not going to get 0 on the bottom, so it's okay. So horizontal tangent would be at 1 comma. The way I find the y value is I plug it in. So f of 1. So negative 4 times 1 over the square root of 2 times 1 minus 1. So negative 4 over the square root of 1, so negative 4. Okay, as always, let me know if you need any help.